Alright, so today we're going to talk about circles and lines. And when you have a line, there's basically three ways it can be used with a circle. One is a circle and line can have no intersection. Not much to talk about here. The second way is that the line intersects the circle 2 times, shown here. And then finally, the one we're going to discuss today is if the line just touches the circle 1 time at one point along the circle. And this is called a tangent line. And there are special properties when a circle and a tangent line touch one another. And I think we can make the discovery by just taking a look at the following page here. If I start with a T here where I know there's a right angle between the 2 line segments, I can take and put that T, and I use the one leg as a radius, and you can see that that's a tangent line. And we know that it meets at 90 degrees. Well, think about it. As I rotate this T, it doesn't matter where I put it on the circle. It is still going to be, there we go, tangent at that point. It still touches once here, and it's 90 degrees. And it doesn't matter as I rotate this around. If I group everything, as I spin it around, it doesn't matter. The circle doesn't change as you rotate. The radius here is perpendicular to the tangent line every single time. So if you have a line on the outside of a circle and you have the radius, when you pick the radius to it and touch it at one point of intersection where the radius, the tangent line, and the circle all meet, that is a 90-degree angle. That allows us to do certain types of problems. One of the classic problems is this. Those lines touch once, and we know then, this is not too well to scale, so I'll fix it a little bit, that these will meet at 90 degrees. It also then tells us, since these are 90 degrees, we're going to know that this splits, so these are angles are the same. We know these are the same. Angle, angle gives us angle, angle, angle. And then since these are the same length, we have angle, side angle. And all of a sudden we know that this length x is the same on both of these situations. So again, when you have tangent lines, you know 2 facts. One is that they're always 90 degrees, and if you have similar tangents, they will be equal length. And a lot of the problems are pretty simple when you start talking about practice. 8, m. What's m have to be? M has to be 8. All right? Or sometimes we use Pythagorean theorem. Say this is 13. And we have a radius of 5. Or we have a, I'm sorry, let's make that 12. We'll make the math a little easier. We'll make that 12, and we have a radius of 5, and they want you to find x. Well, you realize that's the hypotenuse of that right triangle. And if you use Pythagorean theorem, you can work your way down. This is a Pythagorean triple, 5, 12, 13 squared root of 169. Those are the problems. You need to try to practice a few of them and use the examples. And again, this is tangent lines combined with circles.